Well, I suppose it's 9:35, and I ain't too good to talk to an empty room, so I'm just going to roll here and see who jumps in the middle. So we talk about using the native digital inputs and digital outputs to um, tie your compressor into the client system. Most every modern air compressor comes with a couple of different ways to do that. Probably one of the most commonly used ones are going to be your fault contacts or your alarm contacts, whatever you want to call them. This particular model, this is Solair's latest and greatest STS global controller. So we actually have a set of contacts for faults and a set of contacts for warnings. And these are what is referred to as dry contacts, meaning there is no voltage applied to these from the IO module itself. So what you have to do is you can see right down here where we have a terminal labeled common, we have a normally open and a normally closed. So you would need to provide your own power source in here to the common from somewhere. Doesn't matter where. Could be an external power source. Could be from the power, the 24-volt power supply inside the machine. Can come from basically anywhere. But as long as you don't exceed the rated voltage of these contacts, you're going to be just fine. So you bring your power source into the common here, and then that's going to flow back out via one of these two contacts, depending on what you want this thing to do. So if if you're coming in on common, coming out on normally closed, basically what that means is when this machine is off, you're going to have power flowing out this wire here, or when this machine faults, um, you will have power flowing out this wire here, and then when they open it, do the opposite. So if this machine is sitting here off, this is a dead contact, machine powers up, this powers up, and then when the fault comes along, this will go away. Um, how you tie this in is going to depend greatly on how how you're integrating this. Is this something where you have a system that looks for an input and then alarms when that input goes away, or does it look for an input not to be there and then alarms when that input comes? If it's a light that's on, and if you have this rigged up to a light or something, is that going to be looking for power on fault? So um, that's what you got to figure out beforehand, is knowing exactly what you're tying into with this and what kind of signal it's going to be looking for. So again, just make sure these are usually rated like 250 volts or something, so it's pretty tough to exceed them. Um, so if you're just running like a standard 120-volt circuit or even a 24-volt circuit, you're going to be just fine. Um, Common warning works kind of the same way. It's just that what's going to trigger these is going to be, you get a service warning, or you get the warning before it trips out on high temperature. This is a set of contacts that's going to activate when your machine actually goes into a fault. These are the contacts that are going to activate. And again, it's as wild as your imagination as far as how you use these contacts and what you tie them into. So, biggest thing to remember here is that this is a dry contact. There's no power supplied to these from the machine. You have to bring your own power source. So, um, that pretty well covers the fault contacts and the warning contacts. Like I said, they both basically look the same way. It's just one's triggered by a warning, one's triggered by a fault, and both are tied in however your little heart desires. Um, Next thing I want to get into here is this hot mess up here. So, in the original post I did on this, I was talking about tying this thing. I was talking about tying this thing in to the building lighting system, so that when the lights are on, the compressor is on. When away. Don't come back. Go away. So when the lights are on, the compressor is on. Lights off. Compressor shuts down. Um, this is going to be a little bit hard to read up here, so let me get out of here. So that's all I'm going to do again. Look what I got all lighting interface. Zoomed in nice and close. So what we've got going on right here is this is what we refer to as a basic DI loop. And what that means is this dotted line right here represents a 24 volt DC signal that is generated by the IO module itself, and then it looks for that signal to come back on these inputs to direct this thing at what it needs to do. So we've got remote master, remote stop, user unload, user warning, user fault. These are all things out basically in your client's plant. You know, if thing X happens, I want it to register as a fault on the air compressor. If this other thing happens, I want it to register as a warning on the air compressor. And then of course we have our user unload and all these other things. So we're tying this into the lighting system, which is the example I used in the original post. What we have to do is we have to complete this loop right here. You can see it's actually showing this as open right now. If we want this machine to unload, we have to give that 24 volt signal into input 10 right here. So close this out. Go to this next one here where I have. So the way we would do this is we would take this 24 volt DC signal right here that's being generated by the IO module. We would run this through our relay that's been wired up and given to us by the plant electrician. So this relay is going to change states based on whether the lights are on or off. And we want to come through the normally closed of this relay to give this signal right here to input 10. Reason being, if the lights are on, this relay coil is going to be excited and it is going to change states and these contacts will open. When that happens, that manual unload signal goes away and the compressor will run as normal. When the lights go off and the relay coil is de-energized, these contacts will close and this user unload signal can come in here, unload the air compressor. It'll run for its designated time, whatever that is, 10 minutes, 5 minutes, whatever, and then it will go into standby and wait for this signal to go away. So when you come in the morning, it puts the lights back on, it opens, and the compressor says, hey, it's time to get to work. So it loads and locks and rolls. This is what I would call a basic interface right here. This is pretty simple and just about anybody can get it. If you wanted to take this to the next level, what you could do, what I would do, is you can put a manual bypass switch in. You just throw a two-position switch, put it right into the door, put it next to the controller, whatever makes you happy. So that if you need to defeat this easily, let's say you're there after hours doing some service, or there doing some kind of troubleshooting or something, it's after hours, everybody's going home and you're still there, you just flip this switch to bypass, and now it will stop this signal from getting through here, and the compressor will operate as normal until you flip that switch back to normal. So you can see right now my little drawing here. I'm better at reading these than drawing these. I think it's give you a complete lack of artistic ability, generally speaking. But so this little switch is going to fit in right here where I have this asterisk, and I wrote, hard to see there, but I wrote detail A, called this detail A. So when our switch is in the normal position, this is closed. It's going to allow this relay to operate as normal. Once we flip this to bypass, this is going to manually open this right here, and then it doesn't matter what state this relay is in. No power is going to flow through here because this is open. Once we're done doing whatever we're doing, and we want to put this back to normal, we put the switch back to normal, this closes, and now these relay contacts can operate as normal. Anytime you make any kind of a modification like this, I would definitely put some kind of a bypass switch in to easily defeat it. Obviously, being the installing technician, you would know, all I got to do is jumper this out or do this or that or the other, and everything's fine. But it may not be you that's coming back to work on it. It may be the end user that needs to bypass whatever you've done here, and it's best to give them an easy way to do so. So the even next level on this would be on that two position switch would be to put a normal it's another set of contacts. So when we are in the normal position, this relay can operate as it normally would. This is going to be closed. This is going to be open. When we flip the switch to bypass, that of course opens the circuit right here, so that no matter what happens, this lighting relay has no bearing on anything. But then this, we've got 24 volts coming from our power supply, is going to come through uh, this switch right here. We're just going to put a light on somewhere, whether it's on top of the compressor or wherever it is. Just a little light that's going to light up that says, hey, um, your lighting control relay is bypassed. That way you don't forget to put it back into normal. That's a pretty cheap, easy adder right there that ensures that this thing works the way that the customer wants it to. And that way, if you're there doing service work or troubleshooting work or whatever, and you go to leave and you go, oh crap, that light's still on. Well, okay, you can just flip it back to normal and now you're good to go. So it doesn't necessarily have to be a lighting circuit either. I mean, this user unload could be anything. It could be something from the customer's control system that they go, well, we don't want the compressor to run when we're doing X. So okay, when that process kicks off, give me a dry relay here, and we'll make that happen. Um, I just use the lighting because it's one I've done before where little mom and pop machine shop, and they're just like, yeah, when we come in the morning and put the lights on, we want the air compressor to start. When we leave at night, put the lights off, we want the air compressor to turn on. So, easy enough. And you give them the bypass switch with the light and all that on there just to make things simple. And so yeah, um, that would be our lighting control. The other example I shared in the original post was if you are going to try an emergency stop circuit in the fire suppression relay, and not all compressors have this, but on the Solar, if we are lucky enough, we have a secondary e-stop input. You could do this just as easily, interrupting your regular e-stop circuit as well. You just have to know if that e-stop faults on an open or a closed, and you can set your wiring up accordingly. But we have a secondary e-stop input here, so that's what we are going to use. And so again, we're going to work through this as a basic function here. So we have what I would call a fire suppression relay, and this is going to be supplied to us by the company that does the fire suppression system. And if it's me, I'm going to ask for a relay that is normally open and energized or closes on energized, and I want this relay to be normally energized. Reason for that is if you went with the normally closed contacts to maintain this loop and you relied on the relay powering up to open the contacts and cause your restart fault, well, if that coil all of a sudden decides to burn out or something, you're not going to know it until you actually need this loop. Doing it this way, keeping the relay powered up and relying on normally open contacts to maintain closed, if that relay coil goes bad or something else goes wrong with that relay, you're going to know it because you're going to get a new stop call. Again, something you want to discuss with your end user, make sure that they're okay with that. If it's, we don't want it that way, then you got to do it the way they want it. But this would be my preferred method. That way, we're not finding out the wrong time that, oh crap, we had a relay that had an open or a short in it, and this doesn't work anymore. So again, this is what I would call kind of your basic tie-in. Your fire suppression guy is going to supply this relay for you, and you're just going to wire it up. So again, we can go to our next level, which would be adding that bypass. And this is going to be in series. So you can see this is poorly drawn, but this is normally open. When the switch is in the normal position, this is going to be open. We are maintaining the loop with this right here. We switch this to bypass. This is going to close and maintain the loop. And then it doesn't matter what happens with this fire suppression relay. It's not going to make any difference because the loop's being maintained through this manual switch. Again, this would be just a little 2-position switch. Cut it into the door, mount it on the wall, wherever you want to put it. Doesn't necessarily have to be even local to the compressor room. You could this could be something that's tied into the DCS or the building automation system or something like that, where the operator hits a bypass button on their screen, and then it just maintains this latch while the fire suppression system is doing what it's doing, and it doesn't interrupt the compressor. Once again, we're going to put this 2-position switch in here. These are both going to be open when we're in normal. So we're relying on our fire suppression relay to latch this circuit. And when we switch this to bypass, this contact is going to make. Our circuit is now maintained by the manual switch. And then this circuit is going to make. We have power from our 24-volt power supply over here. And again, we don't want to be using loop power to power anything else other than these inputs. Put that kind of weight on it. So we're going to bring 24-volt power from our power supply into here. This closes. It's going to put this light on, letting us know that, hey, the fire suppression relay has been bypassed. That way, if they need to test the fire suppression system, but they don't want the air compressor going down during testing, it's really easy. They can just flip the switch to bypass, and they're off and running. And the light's there as a reminder to say, hey, turn that back to normal when we're done here. Again, doesn't even have to be a light. Could be an input into the customer DCS that there's a warning up on their computer screen saying, hey, this fire suppression relay and the compressor's been bypassed. Could be a warning light in the maintenance office. I mean, it's literally again, because we're supplying this contact and it's a dry contact, so whatever power we bring in from wherever, and then that power can travel back out to wherever we need it to go. You're pretty much limited by your imagination on that one. So yeah. So that's just a couple examples of how you can tie these compressors in. Again, most modern compressors are going to have some kind of a dry fault contact in them that you can tie into. Most of them are going to have some kind of a digital input for remote load unload. And most of the time you don't get a secondary e-stop. Solairs are kind of unique in that, but you can interrupt a standard e-stop button just as easily. So but again, as I was saying, always, for me anyway, always make sure you've got some method of bypassing what you've installed here, and make it obvious, make it easy. Yeah, that's it for tonight. So hopefully you guys pick something up out of this. Close that guy out. Yeah, if you guys pick something up out of that, any questions or whatever, should get over to you in the DMs. With that, I don't see any questions in the chat. So I'm going to hop off here. Y'all have a wonderful evening.